Hello, beautiful people, and welcome. In this video, we are going to be solving right triangle angle. So the angle is the unknown part in this triangle. Now, it's very important to understand that this is a right triangle. Therefore, we can use SOHCAHTOA. So we're going to be using right triangle trig ratios in order to solve them. Now, not only are we using the right triangle trig ratios, the sine, cosine, tangent, we're actually going to be using these inverse trig functions. So this right here, this symbol is not a exponent of -1. This is the inverse of sine, the inverse of cosine. So this symbol right here is inverse. So it's inverse of sine, inverse of cosine, and the inverse of tangent. So you're taking, when you take an inverse switches the input and output. So originally we had sine of theta, but now we have sine of our ratio, our opposite over hypotenuse, which equals to theta. So let's go ahead and see how we use these inverses in order to solve for our angle. So here we have question number 1. On question number 1, again, we have a right triangle. This is extremely important to note that we can only do this when we have a right triangle. So when we have a right triangle, we have to first choose your ratio. And we have SOHCAHTOA. So do we choose sine, cosine, or tangent? Well, let's go ahead and first identify the information that we have in order to decide what we need. So I have my angle A. This is my angle. This is my, let's go ahead and make this a little bit darker. This is my angle. So this is my eyeball. So looking through this eyeball, give me a quick second. It looks like this is very blurry to me. See if that's any better. So here's my eyeball. Across the street from my eyeball is my opposite. Across the street from the 90-degree angle is the hypotenuse. So that means this side right here is your adjacent. Now that we have our triangle identified or labeled, note the relationship that we have in reference to our eyeball. So what we have is we have 8, which is the opposite, and 12, which is the hypotenuse. So opposite and hypotenuse looks like we're going to be using sine. So what do we know about sine? Well, usually we have sine of theta is equal to opposite over hypotenuse. But now we're going to be using the inverse function. So the inverse function says, hey, take your input, take your output, and switch them. So input was theta, output was ratio. Now we're going to flip it. So the inverse of sine is opposite over hypotenuse is equal to theta. So inverse of sine of opposite over hypotenuse is equal to theta. Well, what is opposite over hypotenuse? Inverse sine of opposite was 8, hypotenuse is 12, and that is equal to your angle measure. Now, I don't know what the inverse of sine is, like what that ratio is or anything like that, so I'm going to type that into the calculator. You're going to press second, and you're going to press sine. What happens is this top section, this inverse sine that is on top of this button, that is what comes up, and that's what we need. So this is, again, not an exponent of -1. This is the inverse function. So inverse of sine of 8 divided by 12 equals, press enter, and it does look like we have 41.8 as our angle measure. Now, please note this symbol right here. I'm going to try to zoom in so you guys can see it better. This symbol right here says degree. This is the measurement units. So if you have degree, that means your 41.8 is in degrees. Now, if you do not see degree here, you're going to press on second. You're going to press this button here. Oh, not that button. You're going to not press second, excuse me. You're just going to press this button. Let's try this again. I'm going to clear this. Press this button right here if you need to change it to degree. If you have radians or gradients, don't worry about that. You're just going to need degrees for the time being. So you select whatever you want, press enter, and you're done. And here we have degrees. Let's do a few more. Ooh, wrong way. For question number 2. Question number 2 is asking us for, again, the angle measure. Now this one, they did not provide us the secondary. So I'm going to choose 5 here. So let's identify what we have, where our eyeball is. So here's theta, here's our eyeball. Across the street from our eyeball is our opposite. Across the street from 90 degrees is our hypotenuse. And so that means this guy right here is our adjacent. So let's set up our SOHCAHTOA. SOHCAHTOA. And we have an adjacent and we have an opposite. Adjacent and opposite is our TOA, which means we're going to use tangent. So tangent of theta is equal to opposite over adjacent. But again, we are now trying to solve for an angle, so we're going to be using the inverse function. So inverse function is inverse of tangent of opposite over adjacent equal to the angle theta. So tangent inverse, or inverse of tangent, the opposite was 13, the adjacent was 5, and that's equal to our angle measure. Again, let's type that into the calculator. This is in degree mode. So we have tangent, so second tangent of 13 divided by 5, and that's going to be equal to our angle measure of 68.96 degrees. You can round that to 69 degrees for your theta measure. I'm going to shift that up, give you a moment to write that down. As always, please pause the video if you need a chance to write anything down. All right, let's go ahead and move on. Took 2 papers instead of 1. For question number 3, once again, let's go ahead and label. Now this one did not provide a theta for us, so I'm going to select a theta. Let's make A our theta. Here's our eyeball. That means across the street, here's our opposite. Here's our hypotenuse. And that means this is our adjacent. Okay, let's go ahead and write out SOHCAHTOA. So for SOHCAHTOA, we have an opposite and adjacent. Opposite and adjacent, just like in the previous example, would be our tangent. So tangent of theta is equal to opposite over adjacent. Since we are now trying to solve for an angle, we're going to take the inverse. So we have an inverse function, which is inverse of tangent of opposite over adjacent equal to theta. So tangent inverse, or inverse of tangent of opposite, is 15.6. Adjacent was 6.6. And that equals to our angle measure. Let's go ahead and type this in. Tangent, inverse, or inverse of tangent, 15.6 divided by 6.6. And that's equal to 67.06 or 67.1 degrees. Let's do another one. Now this one is not giving us a picture, so we have to draw it. They do tell us something extremely important. Now we cannot do this SOHCAHTOA, we can't use the inverse if they do not tell us this piece of information. They have to tell us we have a 90-degree angle, we have a right angle. If they do not tell you that you have a 90-degree angle, that means you don't. So you cannot use right triangle trigonometry when you don't have a right triangle. So extremely important that this is a right triangle. So let's draw this out. How your triangle looks like doesn't really matter, as long as C is your 90-degree angle. The A and the B, capital, don't matter. The lowercase b is across the street from uppercase B, and the lowercase a is across the street from the uppercase A. So when you've labeled that, let's go ahead and input our information. They do want us to find the measurement of A, so we don't know. This is our eyeball. However, they did tell us little a is 7 and little b is also 7. So let's see what we have. We have our eyeball here, so this is our opposite. Across the street from 90 degrees, this is our hypotenuse. So that means this is our adjacent. So let's see what we have. We have an opposite, we have an adjacent. So once again, SOHCAHTOA Opposite and adjacent, we're using tangent again. We seem like using tangent a lot this time around. Tangent of theta is equal to opposite over adjacent. So the inverse function would be opposite over adjacent is equal to theta. And that would be inverse function of what was our opposite 7. Our adjacent was also 7. And we're going to plug that in. So we have inverse tangent 7 divided by 7. And that gives us theta is equal to a beautiful 45. Now in this case here, you did not have to use the inverse function if you notice that this side length is 7 and that this side length is also 7. That means these side lengths are congruent. And if you have a congruent two segments and a 90 degrees inside that triangle, the only option you have is an isosceles triangle, which is the 45, 45, 90 triangle. But if you didn't notice that, that's fine. You can always use the inverse. All right, let's go ahead. Question number 5. Once again, they did not provide the picture for us, so let's go ahead and draw a picture. Super duper important that they do tell us we have a 90-degree angle or a right triangle. Drawing the picture. Let's draw it out this way. It doesn't matter how your picture looks like as long as you do have that 90-degree angle. C is that 90-degree angle. A and B placement doesn't matter as long as little b is across the street from big B and little a is across the street from big A. We have the measurement of B that we want. We also have that little b is 11 and that we have little a is 12. And so let's go ahead and label. I'm already chuckling because I think I see a tangent coming up. So across the street is our opposite. Across the street is our hypotenuse. And I do, you guys can't see that. And in fact, I am chuckling a little bit more now on the inside because I do see that we're going to need to use tangent once again. And here's our adjacent. So we have opposite, we have adjacent. Again, SOHCAHTOA. So for SOHCAHTOA, we have adjacent opposite. So we have tangent of theta is equal to opposite over adjacent. Take the inverse, so inverse function equals theta. So we have tangent inverse or inverse of tangent. Opposite was 11, adjacent was 12. Type that into the calculator. Now all of these examples almost all of these examples did use tangent. However, just make sure you mark up your triangle and see which ratio you do need to use. It will not always be tangent like we are doing now. So we have 42.5 degrees for our angle. Now for question number 6, this is asking you to solve the triangle, meaning solve triangle means find all the angles and sides. So all of the missing angles and all of the missing sides. So they will not give you a theta because you have 2 unknown angles. They will not tell you which angle to find first. It is your choice. All you need to know is you need to find all of the angles and all of the sides. So let's first point out what we do have. We have 2 measures, 2 side lengths. What we can do, because right now, the only thing I know is this is a 90-degree angle, we can use, again, 90 degrees, the Pythagorean theorem. And we can use the Pythagorean theorem to solve for the hypotenuse. So we have 6 squared plus 4 squared equals this x squared. You can put c if you want. So we have 36 plus 16 is equal to x squared. Let's use our calculator for that if you need to. 36 plus 16, that's 52. We're going to take the square root of that. So we have x is approximately 7.2. So we have now completed all sides. Now we need all angles. We're going to, because this is a right triangle, we can use SOHCAHTOA. Which ratio you use does not matter as long as you identify the angle that you need in relation to that ratio. For example, if we are using B, we're trying to find B, like this is our unknown. If we are trying to locate B, the size of it, then this case, this would be our opposite. This would be our hypotenuse. And this right here would be our adjacent. If I was trying to find A, then our opposite and adjacent would be different because our point of view is different. So if we are using this, let's use cosine since we haven't used cosine before. Why I'm choosing cosine? Because it's random. And that's equal to adjacent over hypotenuse. We need to solve for an angle, so we're going to take the inverse or use the inverse function. So cosine inverse or inverse of cosine, adjacent was 6, hypotenuse was 7.2. We're going to type that into the calculator. So inverse, let's clear that. Inverse cosine of 6 divided by 7.2. Close that up, press enter. So we have our angle measure. I'm going to shift that up. Our angle measure of 33.557. So we're going to round to 33.6 degrees. Since we now know that angle B is 33.6 degrees, you can choose to do the inverse one more time if you'd like. But this is what we have right now. I'm going to draw this triangle one more time, just a little bit smaller. We have 90, we have 33.6, and we also need to find the measure of A. So this measure of A is unknown. So we can use something that we learned earlier about triangles, and that is that interior angle sum of a triangle is 180 degrees. So that means 90 plus 33.6 plus something else is equal to 180 degrees. So on my calculator, I'm not going to use any trigonometry. I'm going to use a theorem that we learned earlier. 180 minus 90 minus 33.6, and that's equal to 56.4. So that means, let me use a different color, that this measurement of angle A is 56.4 degrees. And you have solved the triangle. You have all of the missing angles, all of the missing sides. I will go ahead and highlight all of the stuff that we found. This is angle B. This is our side. This is angle A. And we just had those three pieces of information in order for us to find. Let's do one more. Last one here. Same thing. We want to find all the angles, all the sides. In this case, they did give us an angle measure. So happy dance here. Because right away, we can take 180 and subtract this 90 degrees and 29 and this unknown, right? This is our unknown right now. So 180 minus 90 minus 29, that gives that this measurement of angle B is 61 degrees. So now that we have solved for all of the angles, let's solve for the sides. So solving for the sides, we're going to, again, because we have this right here, this is your 90 degrees, right triangle. And anytime you have a right triangle, you can use SOHCAHTOA. If you do not have a right triangle, you cannot use SOHCAHTOA. This arrow looks a little weird, that's okay. Okay, so since we can use SOHCAHTOA, notice that I have two sides that are missing. So let's choose an eyeball. It doesn't matter which eyeball. I'm going to choose A as my theta. I'm going to choose A as my eyeball. So since I am in the point of view of A, across the street would be my opposite. Across the street from our 90-degree angle is our hypotenuse. And this one would be our adjacent. So let's go ahead and use that piece of information in order to find what your missing ratio is. I'm going to say, I'm going to start with, well, what do I need? I need an opposite. Which one has an opposite? Well, I have sine of theta, which is opposite over hypotenuse. And I have tangent of theta, which is opposite over adjacent. Now, which one does not have two unknowns? If I choose sine, notice that I have opposite here that's unknown, but I also have this hypotenuse that is also unknown. So I unfortunately cannot use sine because there's too many unknowns. So I'm going to use tangent. Tangent of theta is equal to opposite over adjacent. Well, what is our theta? What is our eyeball? Our eyeball was 29 degrees. Opposite, we don't know, so I'm going to put an X. And adjacent, we did know what adjacent was, and that was 6.9. Now, our goal right now is to solve for X. Get that X by itself. What you're going to do is you're going to take that denominator, multiply both sides by 6.9. Now, tangent of 29 is just some number. I don't know what that number is, but my calculator does. This 6.9 and the denominator of 6.9, they undo each other. They cancel out. So you have 6.9 times tangent of 29. And the best part here is all we got to do now is type it into the calculator. 6.9 tangent, not inverse. We are not solving for an angle. We are solving for a side. Only use inverse if you're solving for an angle. This is a side length. We don't want inverse. We just do the regular tangent. Type everything in, and so now we have our answer. X is equal to 3.8-ish. We are rounding. We do not have units. We do not have degrees. This is a side length. So that means this X, what was X? X was opposite. So opposite was 3.8. So this right here is 3.8. Now that we do have an opposite, we have choices. We can either use the Pythagorean theorem because we have two sides, we need to find the third one, or we can use this sine that we wanted to originally. I'm going to choose to use sine. So sine of theta is equal to opposite over hypotenuse. That means sine of 29 degrees is equal to opposite, which is 3.8. And the hypotenuse, I'm going to put h because we don't know what that is. Now this one's a little bit tricky because your unknown, your h is in the denominator. But don't let that worry you. Do exactly the same thing we did when we were working with tangent. Take your denominator, multiply it both sides. Now our denominator is h. We're going to multiply both sides by h. So h times sine of 29 is equal to 3.8. This h and this h, they undo each other, canceling. Now our goal is to get h by itself. We want to know what the hypotenuse length is. So I'm going to take this sine of 29, the entire sine of 29, and I'm going to undo that multiplication by dividing by sine of 29, the entire thing. Now what you do to one side, you have to do to the other. So you're going to have sine of 29 on both sides. The sine of 29 and the sine of 29, they cancel, they undo each other. So now we have on here 3.8 divided by sine of 29, and we're going to press enter, and our hypotenuse is 7.8-ish. We're going to go back up here, and our hypotenuse was about 7.8. So we have one thing, two things, and three things that we found in this triangle. All right, beautiful people, thank you so much for watching, and I will see you in the next video. Bye!